Hi Algebra 2 students, happy Memorial Day weekend. This is a little video for you guys. I'm going to just run through some of the problems in your review packet. So I picked out some problems that I thought that might have tripped you up or might be some of the more difficult problems. And then I'm also going to post solutions and we can go over any final questions you might have in class. So I'm going to start with number 4, f composed with g of x. So that means f of g of x. And g of x is x minus 6. So that means we need to find f of x minus 6, or plug in x minus 6 for the x spots in f of x. So there's two x's in f of x, so I'm going to replace them with an x minus 6. So that will look like we will have 2 parentheses x minus 6 squared minus x minus 6. And it's important that you put the x minus 6 in parentheses, the second one, because that negative is going to end up getting distributed in. And if you don't have parentheses, you're going to get something different. So now we need to simplify. We're not quite done. So I'm going to expand the x minus 6 squared. That's going to become x squared minus 12x plus 36. There's still that 2 out front. Then I'm going to distribute the negative, so we have minus x but plus 6. So now I'm going to go ahead and distribute the 2 into the parentheses, so we get 2x squared minus 24x plus 72. Bring down the minus x and the plus 6. Now all I need to do is combine like terms. So we are... Oh, you know what? I just realized I made a mistake from the beginning. That this is a plus 6, but I put in a minus 6. So I'm just going to go through and change all of these signs. Sorry about that, guys. So if you notice, I've now changed all my plus signs to minus signs. So these are all pluses. This is a plus, but that means these two are minuses. So make sure you have that right. Okay, so now 24x and negative x become 23x, and then 72 minus 6 becomes 66. So we end up getting 2x squared plus 23x plus 66, and that would be your final answer for number 4. Okay, moving right along, let's look at number 11. So this is g composed with f of x, so that means g of f of x. And f of x is the rational function, so we're plugging this fraction in for the x in 5x minus 1. So we would get 5 parentheses. Where the x was, I'm putting the rational function f of x. So 2x plus 1 over 3x minus 2, and then subtracted by 1. So from here, what can you do? Well, you can think about this 5. It does not, the thing about the 5 is it's like a 5 over 1. So when you multiply it in, you're only multiplying 5 to the top and you're multiplying 1 to the bottom. So your denominator won't change, and you'll distribute the 5 into the terms inside. So you'll get 10x plus 5 over still 3x minus 2, and then minus 1. And that would be your final answer there. Looking at number 13. Okay, so if you're confused by the tables, this hopefully will help. That means r composed with h of 2.5 means find r of h of 2.5. So what is h of 2.5? The idea would be h is this table right here, and 2.5 is an input. It's a t value. So I want to find 2.5 on the t column, not on the h of t column. And then I want to see what is the output when t is 2.5, h of t is 2.0. So that means h of 2.5 is 2.0. So I can replace that h of 2.5 with the 2.0, and I get r of 2.0. So now I want to go over to the r of t table and find 2.0 on the inputs. It's right there, so that means that the output would be 1.2. And that's my final answer there. Moving right along to the table, to the graphing ones, if I have f composed with g of 1, that's f of g of 1. So first I'll say, what is g of 1? So I'm going to go to the g graph. locate the x value of 1 and then trace up to the curve and say, what's the y value there? The y value is 2. So then I can replace g of 1 with a 2, and now I'm finding f of 2. So on my f graph, I'm going to where x is 2 and saying, what is y? Well, the point is still on the x-axis, so that means y is 0. And that would be my final answer there. Okay, so let's move on to the next page. So the next page is finding inverses algebraically. So I'm going to start with number 33. So to start, I'm going to switch the x and the y value. So I'll get x is equal to 4 over y plus 1. My first step is going to be to multiply both sides by the y plus 1 to move it up. And on the right-hand side, that it's going to cancel the y plus 1. I'm going to be left with y plus 1 times x is equal to 4. And I could distribute this x in, but ultimately I'm trying to get y by itself. And distributing x in doesn't help me to do that. So instead of doing that, I'm going to divide both sides by x to move it over to the other side. Now I have y plus 1 is equal to 4 over x. And to further fully isolate y, I just have to subtract 1 from both sides. So I end up with y equals 4 over x minus 1. And you can also say that is equal to f inverse of x. Okay, next one I'm going to do is number 34. I'll do a logarithm one for you guys. So in this problem, first step, switch x and y. And now we're solving for this y. I'm going to start by getting the logarithm part by itself. So I'm going to divide this negative 7 over to the other side. So I get x over negative 7 is equal to log base 6 of negative 3y. Now it's time for me to cancel out the log base 6. I'm going to do that by raising both sides with a base of 6, or exponentiating both sides. And on the right-hand side, that's going to cancel the log base 6. I'm going to be left with negative 3y is equal to 6 to the power of x over negative 7. You could also write that as like negative x over 7. Doesn't matter where the negative sign goes. Okay, from here, I just need to divide by negative 3 to get y by itself. So I would end up with f negative 1 of x is equal to, that's the same thing as y, which is equal to 6 to the negative x over 7 divided by negative 3. Now, you may think, oh, 3 goes into 6 twice, but you actually can't do that simplification because of the exponent right here. So we're going to stop the work there. Okay, cruising along. Let's look at number 39. So in this one, I'm going to start by switching x and y. So I have x is equal to negative 3 over negative x plus 3 minus 1. So lots of negative signs here to confuse you guys. Oh, I forgot to put a y here. Should be a y. Okay, so I'm going to start by adding this 1 over to the other side. So I get x plus 1 is equal to negative 3 over negative y plus 3. The next thing I'm going to do is get rid of, oh, sorry, one sec. Okay, I'm going to move up the denominator of negative y plus 3. So I'm going to multiply both sides by negative y plus 3. And then instead of like foiling here, I'm just going to kind of divide that x plus 1 over to the other side. But let me just rewrite this momentarily. So we have negative y plus 3 times x plus 1 is equal to negative 3. Then I'm going to divide both sides by x plus 1 to move that away from the y. So now I have negative y plus 3 is equal to negative 3 over x plus 1. From there, I'm going to subtract 3. So I have negative y is equal to negative 3 over x plus 1 minus 3. And my final step would just be to multiply the entire thing by negative 1 to get rid of these negatives. So I end up with y is equal to 3 over x plus 1 plus 3, and that's the same thing as f inverse. So that's the end of 39. And my last problem I'm going to do for you guys on this page is going to be 40. So 40 is one of those tricky rational ones, so I'm going to switch x and y. And I'm going to start by multiplying both sides by 7y plus 5. And in this case, I am going to distribute that x in. So I would end up with 7xy plus 5x is equal to 4y minus 1. At this point, I would like to move my terms around so that I have the y terms on one side and the non-y terms on the other side. So the y terms would be the 7xy and the 4y. I'm going to move 4y to the left. Now I have 7xy minus 4y. And then I'm also going to move the 5x to the right. So I'm going to subtract 5x from both sides. So that makes it negative 5x minus 1. At this point, the point of doing that is so that on the left-hand side, you can factor out the y term from the y factor from both terms. So it would become y times 7x minus 4 is equal to negative 5x minus 1. And then from there, I just need to divide by 7x minus 4 to both sides to get y by itself. So y would end up being negative 5x minus 1 over 7x minus 4. That's also f negative 1. Okay, so that concludes page 2. Let's move on to page 3. On page 3, I'm going to go over C from determining if the following pairs of functions are inverses of each other. So the idea is that in order to check this, you have to do f composed with g and g composed with f, and you have to have both of those equaling x, okay? So let's start with f composed with g. So that means that means f of g of x, okay? So I need to take the g function and plug it in where the x is. So this is going to look weird. So I'm starting with the structure of f, we have negative 2 divided by x plus 1. But instead of x, I'm going to write negative 2 over x minus 1. That's my g function that I'm replacing that x with, and then I have a plus 1 at the end from the plus 1 from f. Okay, so what happens here? Well, first of all, I don't really need these parentheses in my denominator because all I'm doing is adding. So negative 1 plus 1 cancels. Now I have negative 2 over x. And remember, when you're dividing by a fraction, you can multiply by the reciprocal. So this would become negative 2 times x over negative 2. And then, oops, your negative 2's will cancel, and you're left with x. So that checks out. Now let's see what happens when we do g composed with f of x. So that would be g of f of x. Okay. So now I need to take this f function and plug it in for the x in g, which would look like negative 2 over x plus 1 minus 1. So again, it looks crazy, but hopefully if this is an inverse, then we'll see some things cancel. So the first thing I'm going to do now is actually multiply by the reciprocal of the denominator of this fraction. To bring it up, because I don't see immediately anything else that can cancel. So if I do that, I would get negative 2 times x plus 1 over negative 2 minus 1. Then my negative 2's cancel, my plus 1 and my minus 1 cancels. I'm left with just x. This checks out. So my answer would be yes, these are inverses of each other. All right, moving along. This is going to, oh, actually I'm going to do one problem on the back, but we're going to do one of the sketching of the inverses ones. I'm going to do B. I'm going to start by sketching in the line y equals x. And then I'm going to pick points. There's some clear points I can pick along this shape. So say that's the point. 1, 2, 3, 4, 5, 6. -6, 1. This would be -4, 4. -1, 4. 1, 2. And 4, 2. And then to draw my inverse, I'm just going to switch points. Okay, so -6, 1 becomes 1, -6. -4, 4 becomes 4, -4. So I can connect those two. -1, 4 becomes 4, -1. 1, 2 becomes 2, 1. And 4, 2 becomes 2, 4. And then if you take a look, if you compare the new function to the original, we can see that they're a mirror image of each other over the line of symmetry y equals x. You can imagine folding along that line and the two shapes matching up. Okay, the last thing I'm going to take a look at with you guys is these tables down here, because we haven't done something quite like this. But the basic idea is that if this is f and this is f inverse, then the x and y values are switched. So if the output here was -12, then, and then we see an input of -12 in the inverse, that means that the output of the inverse should be the input of the function, because it reverses, right? You're switching the x and the y values. So this would become -4/5. So similarly here, we see -9, we see -1/5. So those are basically going to fill in the opposite spots. So this would be -9, this would be -1/5. Similarly here, we see the 0 as the output, where here 0 is the input, so -8 should now be the input. Here we see -3, here we see 1, so we're just filling in the other numbers. And then the last one, we would do -1 here and 7/5. All right, guys, enjoy your long weekend, study, and I'll answer any additional questions you may have on Tuesday.